Alright guys, today we're going to be talking about congruent triangles again. Yesterday when we talked about them, we had to show that all 6 pieces, all 3 sides, all 3 angles were congruent. We are not going to be doing that anymore because there are certain triangle congruence theorems that help that. So today we're going to talk about angle side angle triangle congruence. And that's going to be on pages 48 and 49, okay? So go ahead and turn to 48 and 49 and label them 5.2 ASA Triangle Congruence. That stands for angle side angle triangle congruence. With these triangle congruence theorems comes a lot of proofs. It's mostly what we'll be doing for a little while. So this is page 48. It is 5.2 ASA Triangle Congruence. And go ahead and label 49 the same thing. We will do both today. Okay. So I need you to go ahead and tear out of your book a couple of pages. You don't have to write this down here. I'm just doing it in case you don't hear me. That's 233, 235. Rip both those out. I need to get a pair of scissors. I have scissors right here. Let's go ahead and rip those 2 pages out, and I'll show you exactly what you're cutting out. Okay, this one's going to be really strange, what you're going to cut out and how you're going to cut it out, because there are certain pieces we want and certain pieces we do not want. This is on page 233. 235 we'll get to in just a second. Here's what you need to cut out, and that's cut out some of the edge. Basically, you're just cutting out the words. We don't want all those words. So here's what you need. You need the triangle congruence theorem with that box. You need the example 1, the directions, this pair of triangles, and this pair of triangles, okay? That's what you need. Theorem, directions, pair of triangles, pair of triangles. You can cut this apart if you want to. That doesn't matter. I just did it in one piece. So pause the video to cut out what you need to cut out. I'm going to glue mine in. All right, and now what goes on 49, we'll get in a minute. It's the other page. As in past videos, I'm pretty sure I've said don't throw anything away yet, because you never know. Just don't throw anything away until the end of this video. All right, so let's talk about the angle side angle triangle congruence theorem. One thing that is very important with these is you being able to recognize which theorem you're using. Of course, that's not a problem today because you only know one, but it will be later. So angle side angle, if 2 angles and the included side, that means the one in between, of one triangle are congruent to 2 angles and the included side, the one in between, of another triangle, then the triangles are congruent. So in example 1, we're not doing a formal proof yet. We're just deciding, are these really congruent or not? So we're going to say this is number 1. This will be number 2. So in number 1, we got to decide, are they congruent? So we're looking for 2 angles and the one in between. Let's flip back real quick to yesterday's stuff. So we're doing this one, angle side angle, and in a minute you're going to need to come back, not doing that in the video, and write the theorem down. Here's what it's talking about. Angle, angle, okay, and the side in between. This is why it's called angle side angle. All of these are labeled based on their name. Angle, then a side, then an angle, okay? Notice it's not an angle here, an angle here, and a side. It's always the one in between. All right, I'm going to flip back and let's talk about it. So number 1, All right, problem I have with number 1. I don't have an angle, a side, and an angle on each of these. However, I probably could find this one. So let's find this angle. I'll just do a little scratch work here. 180 minus 74, which is 106 minus 61 is 5, and that's 45, so this is 45 degrees. If you have to find the other one, that's fine. That's not saying it's wrong. All right, so we need an angle, we need a side, we need an angle. So let's start with an angle. Let's start with A. Is A congruent to D? Yes. Angle A is congruent to angle D. There's an angle. Let's do the side. Is the side in between these two angles congruent? Yes. AC is congruent to DF. Do you know how I know how to label them? A is 45, D is 45. C is 61, F is 61. So it's DF. Order matters. Okay, and another angle. C and F. And I only have to use one letter because they're separate triangles, like they're not connected. If they are somehow connected and have the same vertex or vertice, I do have to use 3 letters. All right, so I have an angle, I have a side, which is in between these two angles, and I have another angle. This, therefore, is congruent, and I've got to be careful with how I name the triangles. So, by the angle-side angle congruence theorem, I know that this triangle is congruent to this triangle. I'm going to say A, B, C. Triangle A, B, C is congruent to, got to be careful how I write it, A to B to C. Well, I've got to go D to E, then to F. So there we go. These are congruent. We will have a little more proof in a minute. That's not a complete proof yet. Number 2. Notice this is determine whether they are congruent. The answer could be no in your homework if it says that. All right, I think we're missing this one again right here, because I've got angle, side, angle, so I need angle, side, angle. So let's see what P is. So 180 minus 31 is 9, 4, 149 minus 38 is 111. Ooh, make sure I did that correctly. 31, 39, 31, 38, 69. Yeah, 69 minus 180 is 111. That means these are not congruent. Even if it's 1 degree off, they are not congruent. So we do have to write something down. We do have an angle, we do have a side, and we do have another angle, but this one angle means they're not congruent. So, since angle L is not congruent symbol with a slash through it, to angle P, triangle JKL is not JKL congruent to MNP. If it's not congruent, you need to say which piece isn't congruent that tells you the triangle is congruent. You don't have to list them all out then. All right, page 49. We are getting a piece, again from the book. This is all from 235. Now, pretty much all we're doing from 235 is using the entire page. We're just going to trim it so it'll fit. So you're just trimming it because we're doing it all. Now, thankfully, on your tests and things, you will never have to completely create a proof. You will have to complete them from drop-down menus or fill in the blanks. However, you should be able to do a proof, and your next project is going to be all proofs, actually. I know I'm not at your home or in class hearing you sigh about that, but I know that you got real mad when I said that. I just know it. Okay. So glue this in. The whole page, I just trimmed it down. So from B all the way down, I just trimmed it. It will fit on page 49 perfectly if you just cut the extra off. Page 235 is what that was. Zoom out so you can see the whole page again. Okay, so here's the whole page again in case you need to see. We're actually going to do the proofs now. Okay. All right, the first one's kind of started for us. They're going to tell us, what's going on, what we need to do. We just about the reasons. So for the most part, for the next week, we're just going to be proving triangles are congruent. Sometimes there will be a step after that. Like if we prove that two triangles are congruent, we could actually prove that then if we prove that they're congruent, we could also then prove other things. Like if they're congruent, their pieces are congruent because of that corresponding parts of congruent figures. Corresponding parts of congruent figures are congruent piece. So later, sometimes we'll take it a step further. So let's go and start with example B. So example B says given that A is congruent to C. I'm going to mark the givens. And the first thing you're always going to do is mark the givens and write them down. A is congruent to C. All right, and E is the midpoint of AC. That'll help us in a minute. So A is congruent to C. That is given to us. By the way, if you ever want to, you can actually write both given statements in the same box. It just depends. Sometimes, though, they want you to write them in separate boxes, which is why they give you a certain amount of boxes, which means on your homework, sometimes you might use more boxes or less boxes, and that's fine. All right, E is the midpoint of AC. That was also given to us. All right, our goal is to prove that the triangles are congruent. I want you to notice something. I'm going to get out two highlighters, and I want you to do the same. We're going to do this for a little bit. Your given statements should always be the very first statements. Your proved statement should always be at the end. Always. In a two-column proof. It would be the first sentence in a paragraph proof and the last sentence. I'm going to highlight that down here too, so when you're doing this one on your own, which you will in just a minute. Since there are two of them, they're going to want you to put two of them right here. I need to throw away this yellow highlighter. Alright, let's keep going. Alright, so we've got our givens. This says, and by the way, since we're using angle, side, angle, and that's the only one we have, that means we're going to need one angle, one side, one angle. We already have an angle right now. We're going to need another side and another angle. So it says AE is congruent to CE. Well, okay. But why? Well, since E is the midpoint of AC, that means E is going to cut this into two congruent pieces. That is the definition of midpoint. The definition of a midpoint is that it breaks it into two congruent pieces. Remember, you always use either definitions or theorems as your reasons. Okay? Theorems, postulates, those kind of things. Properties. Okay. I have an angle. I have a side. Here's my other angle. AEB is congruent to CED. Why, though? You should be going back in your notebook if you don't know why I'm flipping and finding out exactly what type of angles these are. I'll wait. Did you figure it out? AEB is congruent to CED because they are vertical angles. And that's the vertical angles theorem that says, hey, these are congruent because they are vertical angles. Sometimes you'll just see vertical angles. You might even see, I doubt it, but definition of vertical angles theorem. All right, we have an angle, we have a side, we have an angle. They're exactly where they need to be. So we have two congruent triangles because of the angle, side angle, triangle, congruence theorem. Now, I want you to notice something. Do you see how they had to use 3 letters? Remember, you have to use 3 letters if there is more than one angle coming off of something, and there was. E has actually 4, but only 2 of them that are inside a triangle, okay? All right, number 7. In part B, up here, suppose the length of AD is 8.2 centimeters. Can you determine the length of any other segments in the figure? Yes. If AB is 8.2 centimeters, well, let's see what AB goes with, since they're congruent now. AB goes with CD. That means CD is 8.2 centimeters. It says explain. The reason that it is 8.2 centimeters is because corresponding parts of congruent figures are congruent. You know, CPCFC. Sometimes you will now see CPCTC. They're interchangeable as long as you have a triangle. I don't care which one you use. And AB is congruent to CD. All right, I want you to pause the video and do number 8. See if you can do number 8. Start with the givens. You can't do the prove part until you know what goes in between. Okay. I'm trying to prove that triangle JML is congruent to triangle KLM. Sometimes, if the picture gets confusing, you can draw them separately. I know they're connected, but if you need to understand, you can draw them separate. That doesn't hurt anybody. JML. Them being connected actually helps you prove it, but that's okay. Okay. We'll label it in both. You don't have to draw this one unless you need to. JLM. JLM is congruent to KML. That's given. I like to number mine. You don't have to. Okay, number 2. JML is congruent to KLM. JML, KLM. Using a different color because it's talking about this smaller one here. And that's also given. All right, let's think about what we have. We have 2 angles. We need a side. The side has to be in between the angles, so there's only one option, and that's this side right here. It only helps us to understand what we're going to be able to say if we look at the combined picture here. We're talking about this side length that they share. They're sitting on the same thing. It is the exact same side length, so they have to be congruent. Here's what we have to think about, though, when we actually say the statement. And we're going to have to go back and figure out why they're congruent, though. LM is congruent to LM. Oh, no, wait. LM 1, 2 is congruent to ML 1, 2. We have to go figure out why, though. I had to switch them around because I have to match up where they come from. L goes to M goes to L, because it's from 1 and 1 and 2 and 2. All right. Here's where you're going to find the reason, and I need you to go look it up. I'll wait. The reason is in the very beginning. The very beginning. In the beginning. But not like that beginning. A little bit past that. It's one of these properties. The property you're looking for says the same thing is equal to the same thing. That's what you need to find. Is the reflexive property the same thing is equal to the same thing? You do have to state that in your proof, even though you don't think you do. It is the reflexive property. It's not of congruence because they're not, of equality because they're not equal. It's the reflexive property of congruence instead. We're just going to say reflexive property, though. We have an angle, we have an angle, we have a side. Now, some of you, it might have bothered you that it's not written as angle, then a side, then an angle. That doesn't matter. As long as it's in the right order on the picture, how you write it in the proof does not matter. All right, last, number 4, angle JML is congruent to angle KLM. And that is by angle, side, angle. I'm going to use a triangle because I'm tired of writing that. Congruence theorem. You can use shorthand if you want to. That does not matter to me as long as you understand what the symbols mean. All right, listen. The only way the proof gets done or you understand it is by you doing it. That's what you're doing today, is practicing proof. Some things you need to know about reasons. They can come off of that 1.4 page that I showed you. They're normally theorems or things like that. It's all going to be something we've talked about before, whether it's definition of midpoint, definition of bisector, vertical angles. It could be corresponding angles if they're parallel, anything like that, okay? We're going to talk about another type tomorrow, but today is all going to be about angle, sine, angle.